So here I'm going to talk to you. So natural inks are used widely for bioink purposes, but there are certain limitations of natural bioinks that I'm going to touch upon on this slide. So they don't always possess a good mechanical properties that is required for specific tissue engineering or organ printing applications. They can be less stable and durable compared to synthetic counterparts, limiting their use in load-bearing tissues or complex organ structures. And also they're often derived from biological sources. The ink can vary depending on the source, that can lead to inconsistencies. And regarding biodegradability, they can lead to loss of structural integrity quicker than expected, before even the tissue has fully developed or integrated into the host environment. So that's one of the issues. And since they are derived from non-human sources, they may trigger immune response, which can affect the transplantation process. And you cannot fine-tune them as you can do the synthetic bioinks. And there are regulatory hurdles because they are derived from biological sources. They may face some complexity. And the next one is slow gelation. We cannot control the rate of reaction, which can be done with the synthetic inks. And the last and the important one, the production of high quality natural ink can be very expensive due to the need of specific source materials and the complex processing steps involved. In this slide, we are going to talk about the advantage of using synthetic bioink. First thing, using a synthetic ink can create a simple system instead of a multi-component system for printing purposes. The very first one is you can tune the properties of the bioink. They can be precisely engineered to have specific mechanical, chemical, and biological properties. So they can easily match to the particular tissue or organ. And they are well-designed synthetic bioinks, so that can make it very highly biocompatible. And since they are synthetic, they are less likely to cause any allergic response in the body when implanted. And we can control the rate of reaction with the synthetic bioinks and with our technology. And synthetic bioinks are often more stable over extended period of time as compared to the natural counterparts. And you can scale up with greater consistency, making them suitable for industrial and commercial applications. And yes, they have a controlled degradation profile, which is very important, which allow them to match the material breakdown and regeneration rate. This control is very essential for tissue engineering and regeneration processes. And we can also add growth factors to make it more cell viable, so they can enhance the cell addition, proliferation, and differentiation process, make it more cell viable. And the regulatory pathway should be easier with synthetic bioink as compared to the natural ones.